Hi guys, this week we are talking about winds. Before we get started, let's do a quick review of the differences between weather and climate. So weather are the conditions that are happening right now, and climate are the weather conditions over a long period of time. So if it's raining, that's weather. If it's an arid climate, that would be dry, that would be obviously climate. Examples of climates are tropical, temperate, and tundra. You learned about them last year in 6th grade when you talked about the biomes. Also very important when we talk about winds are latitudes and longitudes. Latitudes are the horizontal lines that run across the globe. You can remember that because it sounds like ladder, and they look like the rungs of the ladder. So at the equator, that's latitude 0, and then -90 and 90 are the poles. This would be 90, and this would be -90 in the south. Longitude is the opposite. They run vertically up and down. Longitude of 0 is the prime meridian. It's runs through Greenwich, England. And actually the global time, the time of 0 is the time of the prime meridian in Greenwich. Longitude doesn't have the same effect on climate that latitude does. As you go up in latitude, your temperature changes. So this is very warm temperatures at the equator, and then at the poles, very cold. But when you look at longitudes, you don't have the same effect. The last keyword before we start talking about different winds is convection. Convection is something you also have learned about before, but basically as hot air rises, it cools and then it sinks and it creates this circular motion that's called a cell. So as the air moves, it creates this sort of circular motion, and that's called a cell. Just remember, the hot air always rises and the cool air always sinks. Like we talked about in class, that's because the cool air is more dense, there are more molecules that are packed together than the hot air, where the molecules are spread more apart and it's less dense. Things that are less dense have less mass, so they rise. The first two types of winds that we're going to talk about are sea breezes and land breezes. Sea breezes are the reason that it's often windy as you get close to the beach. And it's basically convection. What's happening is during the day, the land heats up a lot more quickly than the water does. And that's because water is a really cool compound that has a very high specific heat, like we talked about when we talked about the burning money. So water can hold a lot of heat before it starts to get hot. That's why it boils at a high temperature, 100 degrees Celsius. The land, however, gets hot very fast. That's why you might burn your feet if you walk on the sand on a hot day. So what happens is the warm air that's above the land rises, just like in convection. As it moves, it cools and then cycles back around. So this is basically just a convection current happening here, but it creates this cool breeze that comes off the ocean during the day. The opposite is a land breeze. At night, the land cools off much more quickly than the water does. So the water will stay pretty much the same temperature throughout the whole 24 hours because it heats and cools so slowly. But the land will cool off very quickly. So if you walk on the beach at night, the sand might feel pretty cold. What happens now is that the cycle switches direction, so the warmer air is coming off the ocean and is sinking over the land, creating this land breeze that's blowing out to sea. This will happen at night. A sea breeze will happen during the day. Another type of wind is the jet stream. Jet streams are very strong winds in the upper troposphere. They're very high-level winds compared to the others. So remember that the weather on Earth is happening in the troposphere, and then as you get higher up, you're getting less and less weather, but high up in the troposphere, you do get these jet streams. There's two jet streams, the polar jet stream and the subtropical jet stream. Subtropical is red because it's warm, and the polar jet stream is cool or cold. So what happens is these currents can kind of shift around and allow the warm air or the cool air to extend further into the land below. So right now, the United States is getting warm weather. But if this polar jet stream were to dip down, this cool air would be allowed to extend into the United States, causing cooler weather. Generally, these are about in the right locations in terms of latitudes, and so they can be determinants of climate. I also want to talk about the Gulf Stream here, which is not a wind current, it is an ocean current. So very important that it's not a wind current, it's a surface current in the Atlantic Ocean. It causes the land that is close to this current to remain warmer, even in the winter. So we are very much affected by the Gulf Stream. We have more mild winters than somewhere on our same latitude might that's not on the Gulf Stream. Very, very affected by it is Iceland and England. They stay much more mild compared to Greenland because Greenland is not getting the warmth of the Gulf Stream. Here's another helpful image of that. So the Gulf Stream is moving north. Iceland is getting the warmth of that. England is getting the warmth of that. But Greenland is getting this cold current. So even though it's the same level of latitude as Iceland is, it's a glacier. This is a glacier. The white is a glacier, whereas Iceland is mostly tundra. So still cold, but much less cold. The last big factor that affects winds is called the Coriolis Effect. So this image is showing convection cells. This is what would happen if the Earth wasn't spinning at all. This convection would happen, but no movement to the left or right. Because Earth is rotating on its axis, the winds also will rotate due to the Coriolis Effect. So the Coriolis Effect is causing winds to flow to the right north of the equator and to the left south of the equator. And that results in these very specific types of winds that flow in these certain areas. You can think about this as relating to what we did in physics with inertia, where the winds are in motion and they stay in motion along with the motion of the globe. Here are two images that show the effects of the Coriolis Effect. So when something's fired northward, it will curve, and when it's fired southward, it will curve in the other direction because the Earth is spinning on its axis. Here's a description of the different winds that you would find in each of these areas. So closest to the equator, you get the trade winds, and then the westerlies, which are called that because they're flowing west, and then the polar easterlies, which of course are flowing east. These are things that your explorers would have really had to know about because these winds would have been powering their ships since their ships didn't have motors. So the trade winds and the westerlies, probably not so much the polar easterlies, but these two wind patterns would have been really important for them to know about as navigators. The Coriolis Effect also contributes to the large size of hurricanes, and it causes the winds to spin counterclockwise in the northern hemisphere, so our hurricanes spin counterclockwise, and then in the Pacific, where they're called cyclones or typhoons, they spin clockwise, the opposite direction, because of the Coriolis Effect. That's it for this time. Hope you learned something about winds, and I'll see you next week.